Hey everyone, thanks for joining us this morning. We're going to get started as soon as I see the attendee numbers start to slow down. We're still seeing people trickle in, so we'll probably get started in a minute or so. So just bear with us. Once we're comfortable with the numbers, we'll get going on the content.
Rohit, what time is it where you are?
6:30 p.m.
Okay, oh, that's not that bad.
Yeah,
Thanks for spending your evening with us.
absolutely. Happy to be here.
All right, I've seen the numbers start to plateau, so I think we'll go ahead and get into it. First of all, thank you everyone for joining us, especially early in the day, depending on where you are. For Rohit, as you probably heard from Taylor, it's late in the day, which is why this is so early in the day. So maybe that makes sense now. But we're here today to talk about the topic of the day, which is the GPU advantage for cloud acceleration. Obviously, there's a lot of different emerging and longstanding use cases for GPUs, and as we've worked to bring OpenCloud to market, we knew this was going to be one of the first things that we needed to get to work on behalf of our customers. And so what you're going to see today is a really early look at some of the work that we've done in partnership with our partner ShapeBlue on bringing multi-tenant GPUs to the Cloud Stack open source project. First of all, we're going to get some introductions so you kind of know who's who in the zoo here. So Taylor, over to you.
Yeah. Hi, everybody. My name is Taylor Greiner. I'm the Director of Innovation here at US Signal. Really excited to be a part of bringing GPUs, to OpenCloud. Just a little bit background about myself. Been in software development, cloud architecture for over 10 years. Really focused on kind of all areas of the service provider. So I've been in sales, I've been in product, I've been in engineering, but excited in my role helping lead the R&D team and bringing products, research and technology to hand over to David to bring to market.
Awesome. Thanks, Taylor. Rohit, since you're actually the guest, I'm going to go to you next. I'm going out of order. I'll go over to you.
Thank you, David, and thank you, Taylor, for both having me here. My name is Rohit Yadav. I've been working on the open source cloud management platform called Apache Cloud Stack since 2012. I'm the PMC member and committer of the project. And I think for the most part of my career, in fact, all of my career, the only thing I worked on is cloud computing. My journey started in CERN in Geneva, and I've worked at Citrix in the past, and now I've been working with ShapeBlue since 2014. Majority of my career was in software development, but these days I also do a lot of focus on roadmap work, strategy, and leadership around the open source project. At work, I'm the CTO of ShapeBlue. We are the world's largest independent integrator of Apache Cloud Stack project, and I live in Gurugram, India. So back to you, David.
Awesome, great. Thank you, Rohit. Again, my name is David Humes. I'm the Vice President of Product Development here at US Signal. I've been with the organization for just over 2 years. About half of my career has been in the data center infrastructure space. And then the first half of my career was really actually spent on the side of a customer. So consuming, infrastructure as a service, private cloud services, backup services, fiber optic services. And so we really here at US Signal, one of the things that, Taylor and I on the sort of pre-go-to-market product side is try and bring our customers along. And so what we're going to show you all today is really about, what's coming in OpenCloud, not just what you can do today, but then what's coming. And so hopefully it introduces everyone to a bit of the art of the possible. So as we think about what we want you to take away from the discussion today, it's really this, I think somewhat undeniable fact that GPU acceleration has become essentially essential for modern IT infrastructure and application environments. The obvious big one, and you'll actually see a demo from Taylor today around how OpenCloud plus GPUs can help enable things like large language models. But there's also like the current state needs in many businesses around GPU accelerated virtual desktops, for example. And so again, as we brought OpenCloud to market, one of the things that we knew about the Cloud Stack project was that while it had GPU functionality baked into the platform, what didn't exist was this idea of GPUs as a first-class citizen with the ability to provision a GPU in a multi-tenant environment. And obviously, that's in large part what OpenCloud is today. And so, we really wanted to make sure that we step you through it. So again, what we're going to do is I'm going to give you just a quick overview of OpenCloud if you're not familiar, as well as what we're doing as an organization, just so you have the context. I'll talk briefly about why GPU as a service is important. I think I've touched on it, but we'll go a little bit deeper. Then I'm going to hand it over to Rohit. Rohit may know the most about the Cloud Stack project as an individual contributor of possibly anyone in the world. I'm sure he would argue that point, but we've got the guy here. So he'll talk about the GPU integration project from like a design and architecture perspective. I'll give you an idea towards the end where we think this is going to end up from a go-to-market timeline when you can actually start consuming this. And then Taylor's going to go over a demo where we actually deploy an OpenCloud instance and run an LLM with a GPU attached to it. And then we'll do a live Q&A at the end. Just a couple notes about the Q&A. In GoTo, there is a comments box. Don't use that. Use the question mark box. I will see questions as they come in live. If it makes sense to handle the questions as they come in, we'll just do that. If not, we'll wait till the end and we'll address the questions in order, but don't feel like you can't wait to put a question in the box. And then the last thing, and I'm going to hit this again later, we have a survey. It's very brief. It's three fields to fill in. And I really ask that if you've taken the time to attend this webinar, you fill out that survey. And the reason that's important is this is still very early in development. We have a pretty good directional idea of what we're going to do here, but the details in terms of what GPUs we have, where they're deployed, what applications they're optimized for, that's really all of you to help guide our roadmap in terms of what we build. We can do a lot of different things. We want to make sure that what we do is really aligned with the needs of our customers or potential customers. So just getting a little bit into US Signal in case you're not familiar. We're a data center and network infrastructure company based in Grand Rapids, Michigan, founded in 2001. We really view our business as two key core competencies. So it's the network, which is really the history of the business, which is where it started. And we have an exceptionally strong pedigree in solving really complex connectivity challenges. And then obviously also as a data center services provider. So that's our fleet of 16 national data centers. It's the cloud services that we deliver out of those. It's the managed services out of those. We really view it as the two core competencies to try and be really the best at whatever it is we do. And then we do these things we call one-step adjacencies, which are security, managed services, and cloud. These are things that we think we can do well within the context of these two core competencies. So as I mentioned, we have 16 national data centers right now. We have 2 edge data centers, which are in Des Moines and Michigan, that are under expansion right now to add power capacity based on customer demand. And then we have 8 micro data centers under construction along a 1,000-mile fiber route that is being built in various parts of the United States. Today, we have about 3,000 customers across the United States. And from a cloud perspective, OpenCloud is obviously the topic of the day. We also have Nutanix Rely Cloud, as well as support for Azure as a CSP and managed service provider. And then one of the things that I know our customers love is the technical operations center that's staffed by engineers 24/7, where you can call and get a real person who actually knows what they're talking about within 30 seconds. So if you're not familiar with OpenCloud, I'm just going to provide a brief overview from an executive summary perspective. OpenCloud is really built in response to a lot of the changes we've seen in the both virtualization and cloud market in the last, let's say, 2 years. We have a history of being a pretty large infrastructure as a service provider with another platform. And as that organization has changed their direction in the business, so too have we. And so early in 2024, we set off to build what became OpenCloud, and we didn't know it was OpenCloud at the time, because we really viewed our responsibility as an infrastructure provider to our customers as one where, it's not just good enough to only take our customers' money and run the same platform in perpetuity. We really need to figure out how to protect customers, how to innovate, how to increase security, compliance, all those things. And so we went through a process. No secret where we ended up since you're on this call. We ended up choosing Apache Cloud Stack and KVM as the underlying technologies for OpenCloud, which I'll get in here in a second. Why did we do that? The flexibility that is innate to the platform. So historic, like VMware or even Nutanix, are really more like virtualization as a service than they are true cloud. What we love about Cloud Stack is that it really brings cloud-like functionality to a private cloud environment, which I think is that sweet spot where many of at least our customers are really looking for today, as well as being able to do things like infrastructure as code, which some of the legacy providers don't do very well. And so we like that it straddles that line, and then we can do things like add GPU functionality. Because it's built on open source, it's super cost effective. Depends on who you ask, but the very consistent numbers I see are 30 to 40% less expensive, and that's really just because we don't have to pay the underlying tax for the virtualization platform. It also offers long-term cost certainty in a market that has had a lot of volatility in the last couple of years. And then again, we built it with the same compliance and security, which is a separate thing, but I'll put it in there. As we build all of our clouds. So it's SOC 2 Type 2, PCI DSS, HIPAA audited. And so, you're not making a compromise on compliance or security when you choose OpenCloud. And then lastly, it's super simple. You'll see in Taylor's demo, the point of the demo is not to show the simplicity, but you will see the simplicity. Anybody that's logged into VMware vCloud Director or any of the other VMware platforms, it looks somewhat similar. There's a little bit of differences, but I think there's a lot of beauty in the simplicity. So just a bit about what we're excited about for OpenCloud. Again, we think it combines perfectly that public cloud flexibility with private cloud control. We know our customers still care about knowing where their data is. They like being able to call somebody and get real support. They like being, not a minnow in an ocean. They like being a larger fish in a smaller pond. And so that's really the level of support that we can give to our customers, both on the design and build side, as well as the day two operations and support side. So powered by the Apache Cloud Stack project, which is primarily what we're here to talk about today, with KVM under the hood. So fully open source, very mature project, lots of code committers. And the facts prove that the platform is super performant. We have an overview on our website of a third-party audit that was done on performance. We're as good or better than our competitors. Really great cost predictability in the long run because we don't have a third party that we're beholden to on the cost side. And then obviously security is something that's always paramount. And really what it's designed for initially was focused primarily on enterprise workloads, and that's where we've seen a ton of customer demand. But more and more things like repatriation, that's been a lot of what Taylor does on a day-to-day basis, is working with customers to bring the right workloads, not all workloads, but the right workloads back to a more on-premise solution. And then increasingly AI, which is really the main topic I think of today. So I'm going to talk through the use cases, and then I'll hand it over to Rohit to talk about the integration project. So the obvious use cases, the ones that are very prescient in media, are things like AI in terms of LLMs and SLMs. And certainly, if we look at where the puck is going in a lot of cases, that's really it. And so, some of you on the call that are listening may not have that need today, but you might have that need in 3 months or 6 months or a year. And so, again, going back to what our job is as an infrastructure provider, it's really to provide that art of the possible to our customers and help them realize whatever business or organizational benefits they're looking at. Another one I'll hit on, and then there's obviously a bunch more, but this is one that we're getting a lot of asks for from our customers, is GPU accelerated virtual desktops. So about 2 months ago, we went to market with a desktop as a service solution on top of OpenCloud. That base product is not GPU accelerated. It can still do things like Teams and YouTube, no problem. But of course, we have customers that are doing things like radiology imaging with PACS software, or 3D modeling or stress testing. And so those use cases really require the need for a GPU, but customers may not want to spend the tens of thousands or hundreds of thousands of dollars it takes to actually get there. And so what we're going to be offering to the market is an option to rent a GPU for a period of time, provision a fraction of a GPU, a full GPU, whatever the need is, and Rohit will talk through that architecture. And so we're super excited for what this is going to look like. And then there's all sorts of other use cases in terms of big data analytics, certainly cryptocurrency, blockchain, etc. So let me just briefly talk about the cloud stack integration, and then I'll hand it over to Rohit. Again, when we started this relationship with both ShapeBlue and the cloud stack community, one thing we knew was that multi-tenant GPUs weren't a thing. And so, how do you influence those to become a thing? Well, we're not code writers, but we have a great relationship with ShapeBlue, and so we really approached ShapeBlue with an offer to help fund the development that doesn't just benefit US Signal, by the way. This is part of the Cloud Stack release. So this is available to anybody that's running Cloud Stack as of 4.21. From our perspective, I'll say this later, but I'm going to say it right now. Right now, I consider this as in technical beta in 4.21. So just to be clear to everybody on the call, we are working to productize this internally from an R&D perspective. What you're going to see from Taylor today is running in our lab on GPUs. So we know this works, but we're going to be working closely with ShapeBlue and the Cloud Stack community as we move towards a production ready or stable release in the coming months here to bring this to market. And then, a great thing, supports KVM, which is what we're using under the hood. And then it is GPU vendor agnostic. So NVIDIA gets a lot of the praise in the market today, but AMD and Intel also have some great options depending on the needs of the workload. So Rohit, I think I'll hand it over to you to talk about kind of the current state of GPU technologies, and then we'll go forward.
Thank you, David. I must make one note, which is we have been collaborating on this feature with US Signal for quite some time now. I must acknowledge that US Signal has come out to be a leading supporter of the open source Apache Cloud Stack project. They not only have sponsored and participated in past Cloud Stack events like the Cloud Stack Collaboration Conference, but they continue to engage with the community, engage with us, and help sponsor and support these sort of features. So when David and Taylor here, and also one of his colleague David sort of came to us, and initially we started discussing what would be a future of Cloud Stack having the capability to support GPU as a service feature. We thought, okay, we used to have a legacy GPU support, but we started from scratch, really, right? So we thought, what are the requirements of today, and what can we anticipate the requirements of future? And one of the things was for us to survey the current state of GPU technologies. So we looked at the three vendors that you see here, NVIDIA being the current market leader, but also AMD sort of catching up. And there are some laggards who will eventually sort of may surprise us. And we thought that this GPU integration should not be vendor specific. I know most people who've come to us initially, all initial conversation come to us, let's just find a way to sell NVIDIA's chips over some kind of multi-tenant environment. And that's how most conversations sort of start. But we thought, let's just survey, but let's not make it the core principle of the design. So because if you do that, think about that. In future, if there's a new GPU vendor or different cards actually model of GPUs, then you kind of force yourself into a design and implementation that will prove to become costly to sort of move out to. So we looked at the technology, and we found that more or less there were two ways you can virtualize, three common ways of virtualizing GPU cards. One, of course, is to not virtualize GPU, which means your instances will have one or more GPU cards accessible to them, and the instances make complete use of that. However, in multi-tenant environments, there are certain workloads which are not that demanding. The virtual desktop is a good idea. The sort of multimedia sort of use cases also are good ideas. But there are cases where you need a full GPU pass-through, or maybe multiple GPU pass-throughs, those that require GPU training, AI training, and whatnot. But GPU inferencing, virtual desktops are examples where GPU virtualization can really help and lower cost for of sort of use for tenants and whatnot. So we looked at the two types of GPU instances, the GPU technologies available, and we found that every vendor, in fact, even within vendors, different models, GPU card models behave differently. They have their own sort of driver set. They have their own technologies underlying that differentiate one from another. And taking that, we sort of have a look at the Apache Cloud Stack architecture. So if you look at the Apache Cloud Stack architecture, you'll see at the bottom, you have the physical infrastructure. That's your physical network fabric, your compute, which are your hypervisor bare metal machines that run the hypervisor, storage, and whatnot. On top of that, you run your cloud management platform, which is Apache Cloud Stack. In fact, in this slide, you could replace Cloud Stack with any of the other cloud management platforms like OpenStack, AWS, EC2, and whatnot. And more or less, this architecture will be correct. So what we thought was that this is the current Cloud Stack architecture. It has an API, the Cloud Stack API, that abstracts the underlying infrastructure for users, tenants, automation tools, for the UI, for the CLI, for third-party e-commerce platform that can sort of, let's say enterprises, cloud providers, cloud builders can use to sort of do their own cloud service on top of. And we thought that by including support for GPU, all these layers benefit over a period of time. So if we see the next slide, we'll see that by simply supporting GPU as a first-class entity, and we know Cloud Stack supports multiple hypervisor. Cloud Stack itself is hypervisor agnostic, but as a first step, we have added a GPU vendor agnostic and hypervisor agnostic GPU framework. But as the initial support, it supports KVM hypervisor. And with that, all the other functionality of Cloud Stack, which means Cloud Stack's ability to orchestrate instances through API and UI, the third-party systems, the billing usage, creating Kubernetes clusters, DevOps, Ansible, all those tools using Terraform, for example, they continue to work on Cloud Stack. So we've come up with an idea. Let's create a GPU framework which sits in the Cloud Stack management server you see on the left side here. So Cloud Stack management server is the control plane, which runs in its own host, and it can talk to its database. It abstracts the infrastructure through an API, on top of which the UI, the CLI, tooling, third-party e-commerce platform portals can run on it. And on the hypervisor side, which is on the right side, we see the KVM hypervisor host, is where we run a thin KVM agent, the Cloud Stack agent, that connects to the control plane. And using flexible hooks, this agent can orchestrate GPUs to instances that run on top of it. So here you can see Libvirt and Qemu are running 4 instances, and within the instance, they run GPU drivers that can, depending on what type of GPU you want, the number of GPUs you want, whether those are virtualized GPUs, whether those are pass-through GPUs, sort of this makes the architecture really flexible and possible. The hooks also take care of how the GPUs are discovered, how they are allocated, attached, detached to these instances, whether those are pass-through GPUs, whether those are shared GPUs, and they can be one or more GPUs in number. This architecture also allows a lot of high availability. So let's say you have to do some maintenance in the control plane, your GPU-enabled instances will continue to run, and that doesn't depend on the control plane sort of running in that case. And if you see in the next slide, we show how these, sort of a different view of the same architecture, which is on the KVM host. If there are one or more GPUs available, the Cloud Stack operator, the cloud builder, can decide how they want to split those GPUs. So in this example, for example, some GPUs are passed through, they're dedicated to certain instances, and some GPUs are shared or virtualized by using custom software like the NVIDIA vGPU Manager as an example, of splitting a physical GPU into virtualized or shared GPUs, and the instances sort of consume that. And to make that happen, the Cloud Stack GPU integration feature consisted of a multiple of features. The first one is the GPU discovery, which allows Cloud Stack to discover GPUs on a particular hypervisor host. This will work for newly installed environments, but also existing environments once you upgrade to a version of Cloud Stack which has this feature. The GPU discovery itself is flexible. Again, it uses the flexible hooks customization. So in case there are newer models, there are different vendors, different GPU cards available, an operator or a cloud builder can customize them to their needs. Once GPUs are discovered, CloudStack also helps with host inventory management and classification. The ability to keep track of which GPUs, vGPUs are available on which hypervisor hosts through CloudStack, and being able to specify or classify them in GPU of certain class or model type is what it does. Then it allows the cloud builders or operators to define their own service offerings, which then can be used to map to the usage, the instance usage. This allows cloud builders and service providers and operators to introduce their own billing based on the usage, which tracks the service offerings. CloudStack orchestrates instances with the chosen service offering. So when deploying an instance, which I think Taylor will see in Taylor's demo in a while, one can select the compute offering or service offering, which is GPU enabled, and these service offerings can have one or more GPUs, which are either pass-through or vGPU type. And CloudStack will intelligently allocate instances on host where these resources, the GPU resources by the type and number are available. And in order to ensure that there is fair usage of infrastructure, operator can also introduce tenant limits, which makes which sort of helps put limits on CloudStack account, project, or domain basis to say how many GPU-enabled instances a tenant is allowed to sort of create and use. All in all, the flexible hooks customization make it possible for cloud builders and operators to customize how those GPUs are discovered, how the inventory is managed, and how they are allocated to instances. That's pretty much the feature. And to talk more about the GPU integration advantage that are brought into OpenCloud powered by CloudStack, here's David.
Thank you, Rohit. I first of all want to say I appreciate you spending the time to be with us today. I know you'll be around for the Q&A after. Looking forward to seeing you in a couple months across the pond as well. That'll be great. It was great last year. So yeah, to just talk about the advantages of this approach and maybe put a finer point on it. Because we have this foundation of OpenCloud, which is built on built within concurrently maintainable data centers on enterprise grade, highly available infrastructure, but leveraging open source platforms, we really created the foundation of the house that is high performance, super cost competitive, very predictable, very flexible. And so this lets us do things like work with ShapeBlue to add GPUs. And what happens as a byproduct of that is, we're going to be able to leverage extremely lower total cost of ownership once we bring this product to market, because again, our underlying structure is so sound. Really being vendor agnostic from a GPU perspective, I think is important. NVIDIA, rightly so, gets a lot of the press in terms of the performance of their highest end GPUs. But the reality is, not everybody needs that. Everyone wants the performance, but not everyone wants the cost. And so, we're going to be able to have an offering that, yes, offers the super high performant GPUs, but quite honestly, probably offers the thing that, that most people are looking for out there. Flexible integration, again, what Rohit has talked about is, this is really being deployed in KVM today, but functionality for other hypervisors probably comes in the future, would be my guess. And so, we're loving KVM right now, but as the technology landscape changes, like it allows us to help you go through that. And then again, really leverage itself to the lack of vendor lock-in and open source build sovereign infrastructure as a service clouds. So with that, I'm going to just talk briefly through the overall OpenCloud roadmap through certainly the end of this year and a little bit into next year, and then I'll actually hand it over to Taylor after this slide to go through the demo. So we're obviously here talking about GPU as a service. Again, we've had GPUs in the lab for a couple months now. It's obviously working. You'll see that from Taylor's demo. Really where we're at is, again, the 4.21 release is essentially technical beta for the GPU as a service. And so once the 4.22 comes out, which, Rohit, I'm going to ask you a question I didn't prep you for, but, based on release cadence, like maybe end of this year, early 2026, what's your take?
Currently, we're working hard to get the features in 4.22, and based on the most recent communication from the release manager, who's one of my colleagues, we think 4.22 will be out sometimes in November, worst case, early December this year.
That's great. That's great. So we're on, the US Signal side, we're working right alongside, Rohit, ShapeBlue, and the open source community. So we're trying to be ready to go as soon as it's ready to go and production ready. But a few other things that we're working on, I'm going to kind of bounce around here a little bit. Desktop as a service, as I mentioned, we actually launched and have our first customers being onboarded right now. And again, that's really putting, a VDI platform on top of OpenCloud, which is, again, high performance, lower cost, more flexibility. But what's going to be awesome is once GPUs are enabled and in the production environments, the ability to bolt on a GPU to a virtual desktop for things like, CAD, radiology, imaging, that sort of thing, essentially on day one. There's not really going to be any restrictions there. So we're super excited about that. Other things that are coming unrelated to this conversation, but I'll hit on them real quick. We are working on a product called SyncSafe, which is a replication product to do DR-like things within OpenCloud. That is actually next on our release cadence, so we're working hard to get that done right now. And we know for a lot of customers that's going to be, a requirement for OpenCloud. But the actual really cool and exciting thing about SyncSafe replication is it's an any-to-any platform. So if your ground environment in your current data center today is VMware, that's fine. But if it's Hyper-V, if it's Nutanix, if you're in a public cloud, you're actually going to be able to replicate from that source to our destination of OpenCloud or anywhere, but hopefully OpenCloud because of the performance and the cost with relative ease. So we're really excited about that. Other things which are related to this conversation are bringing Ampere ARM CPUs to our instance types. So those are, if you aren't familiar, they're super high core count, like 192 core CPUs that are really optimized. They're optimized for a lot of things, but probably the prevalent one is small language models. And so as, again, things move, more towards that for, organizations and enterprises where they are running their own SLMs, being able to attach your instance to an ARM CPU is going to be pretty awesome. And then, lastly is this idea of running OpenCloud anywhere. So we have it in a couple of our data centers today. We're planning, based on a lot of customer demand, to expand it in additional US Signal data centers. But Taylor and I are also having customers ask us on a regular basis, hey, could we run OpenCloud in our data center? We're not quite ready to move to a US Signal facility. We're very open to that. And similarly, we may have customer demand in a market where we don't have a data center and it doesn't maybe make sense for us to go buy or build a facility just for that requirement. But we're not opposed to coloing in another facility somewhere and putting our stack there and delivering it to you as a service. So those are the things that we're working on throughout the rest of this year and early 2026. Based on what Rohit said about the release cadence, my guess is we're talking Q1 to Q2 for the GPU functionality. Again, we've got to make sure it's, it's stable and the release is good, but we're working hard on that. So with that, Taylor, I will hand it over to you. I'm going to unshare my screen here.
Perfect. Let's see. Let me find my screen to share. I think this is the right one. Bear with me. Okay. Can you guys all see this?
Yep, I can see the OpenCloud interface. Yep.
Perfect. Okay. So, as we've said here, we're going to demo deploying a GPU-enabled instance and then actually automated deployment of a private LLM running, the ChatGPT experience. So if we start, and we did this recorded just because I was worried with latency, it's running in our lab. We just want to try and have the best experience. And I'm not going to make you sit through long download times for the language model. But if we start, if you're not familiar with OpenCloud, this is the OpenCloud interface. Very simple. So to create our instance, we click Add Instance. And one of the differences you're going to see, and I'm going to kind of pause this as I talk through real quick. In OpenCloud, for our customers, you don't pick what host you get to run on. In the lab, that's something that we have so that we can bounce between different hosts, for testing purposes. But out of the gate, we're going to pick one of our image templates that is GPU enabled, so we've got to make sure as we roll these out, there are different licensing requirements, things like that. So it'll be labeled very easily, right, in production. But again, this is the lab. So making sure we pick our GPU enabled instance. And then in the compute offerings, you'll see we actually have different GPU NVIDIA offerings, right? So what we've got here is NVIDIA L4. Not going to read all those specs, but we've got a NVIDIA L4 GPU that is tied as an offering that we pick. We go through the rest of the deployment process. We pick our data, we pick our network. And then as we move through that, we'll finalize out and give it a name and kick off the creation of it. So we'll let that create real quick, launch the instance, and it's going to kick us back to our screen where you'll see that we're in a stop state. In a second, we're going to, oh, okay, we're kicking this off to run on the host. Yep. Normally in production, it just goes immediately into starting. Forgot about that for a second, but we fired this up. It stopped. It's going to be running here in a moment. And you'll kind of see as we're trying to talk to the instance, here in a moment, it will fire up and then we'll be able to SSH into it. So give that a second. I would click through, but it doesn't actually take that long. So there's longer parts I'll make everyone wait through. This one, I don't want to bounce around too much. So our instance is now started. We'll go ahead, we'll SSH into that, and then we'll be good to go. Yep, so you can see we're now talking to it. And there we go, SSH, and we are in the instance. So now we're in our GPU enabled Ubuntu instance, and you can see here, we ran the NVIDIA command that shows the GPUs, and you can see the GPU specs enabled on the Ubuntu instance, which is really exciting. This is showing that it is alive and working, right? It's enabled. So what we're going to do now is we've got a script. Again, it installs Docker, pulls down, it installs Docker. It installs Ollama, which is a model management tool. It pulls down the GPT open source model from OpenAI and kicks that off to run on this instance. After that, it's going to install OpenWebUI, which is an open source project for a ChatGPT-like experience. And then we'll show that process of being able to log in, kicking off requests, and seeing it actually think and then respond in the screen. So we're going to go through, and this is where I'll kind of jump around because it gets a little long. So we've got this script. It's actually open repo that we have if you're interested. But it goes through, we kick this off, and it starts to run everything. So we're doing our updates. We're going to pull Docker, and then I'm going to let it run for a moment so we can see it run and pull down Ollama, and it shows where it interacts with the GPU. So we're installing Ollama and enabling the service. Only takes a moment. We're about 40% there. We'll sit through this one. I won't sit through where we actually pull down the model because that one takes a moment. So wrapping this up, we're pulling down Ollama, getting that started. We're going to run that. And then right here, you can see, really exciting, Ollama sees that the NVIDIA GPU is installed, right? So now, and sorry if that's kind of hard to read. I don't know how to zoom that in very well. But the GPU is installed, Ollama sees it, and now any of the models that it pulls down are able to leverage the GPU that we have available on the instance. If that GPU wasn't there, Ollama would run in CPU only mode. And if anybody's tried to run a LLM on a CPU only, you understand that's not a great experience. So we'll go ahead, we'll continue on with the demo, and you can see now it's pulling the GPT OSS model, the 20 billion parameters. So this is where I'm going to skip through a little bit, just because it does take a solid amount of time. And we're good. So we've pulled down the model. Now we're pulling down the Open Web UI container, and everything is kind of wrapping up the install. So we'll give that another moment. If you haven't seen Docker or installs before, I know we've kind of got a broad audience. It's not always the most exciting thing. I think it's exciting for us, right, to like watch the log output, but a lot of the times, it's just text on a screen, right? But the exciting thing to know is that we clicked a button and we're about to have a private chat GPT here in a moment as this wraps up. So we'll kind of scroll through this just a little bit faster, and you can see that that's now wrapped up. And so in the video, we're going to hop over, we're going to hit the instance, and we've got Open Web UI available on a GPU-enabled host in our environment. The cool thing about this one, it doesn't talk out to the internet, right? It's not talking to OpenAI. It is private in your environment. You can, I could feed in corporate data, right? And it's not going anywhere, which is really exciting. And then now you can see we asked it a question and it's spitting out responses at a very similar pace to, any ChatGPT, Claude type experience, much faster than if we were running CPU-enabled LLMs in the cloud, which I've demoed before, and it's not near as fast as this. So
we clearly have a Wall Street Bets member on our staff that maybe did this demo. Just a thought. I don't know.
So yeah, I've checked it out before. So it's kind of hard to see, and I apologize, but what we can see here is that it actually tracks the metrics of the tokens that it's outputting, right? And so for response tokens, we're getting 54.95 tokens per second. For prompt tokens, we're getting 1,125 tokens per second, which is, as you look at doing inference on GPUs, right? Very, very respectable timing, very performant. You're going to have a great experience deploying these onto the hardware. And as we look at different GPU types, right, and this is where it's really important that if you are on this call, you fill out the questionnaire that David has put together. We need to understand what GPU types our customers are looking for, right? We could go buy a bunch of H100s and put those on, but that may not be the best use case in every scenario. So we want to make sure that what we're bringing to market is a mix of general purpose, high performant, different scenarios, because there's going to be a balance of cost versus performance, and we want to make sure that we can really support any use case that may pop up. So with that is really our demo. Again, I think, thank you everybody for kind of sitting through watching our recording of it. But again, that's kind of a cleaner experience than making you sit through long model download times.
Fantastic. I always think it's great to see something working versus talk about it working. I mean, sometimes one can conceptually understand how it works, but it's really just like seeing it in the real world that changes the game. So Taylor, thanks for doing that. I think that was really fantastic. All right, so here's what we're gonna do. We've got a few questions. We're on the Q&A section. We're taking this live. None of these were planted. These were not ChatGPT questions that were generated or anything like that.
They were US Signal GPT generated.
Yeah, US Signal GPT. So we've got 3 questions. If you have others to the audience, there's another one. I will make sure I address that question. So make sure you put in the question. So, all right, I'm going to start from the first question we got, which was from Chris. Chris's question was, and by the way, I think I have the answer to this, but Taylor and Rohit, if you have feedback, let me know. The question was, where does the Adobe suite play into this? Does it require a GPU or work on current cloud stack? The answer is both. It works on current cloud stack for sure. We have customer workloads that are certainly running that. But there are certain things within the Adobe suite that do work better with GPU acceleration. So certainly as we bring this into the desktop as a service environment, as we go towards launch, That'll be something that will, you'll be able to unlock right away. I don't anticipate any issues with that whatsoever. Adobe's usually pretty good about compatibility with that kind of thing.
Yeah. If you're trying to do some advanced After Effects stuff or something super graphics heavy or video generation, things like that, GPU is gonna be a better experience. But there are products in the suite that people are running, CPU enabled only every day.
Yeah, there's a lot of 2D workloads still in that actually, really operate better on CPUs. All right, Rohit, this question's probably directed at you, although I think I know the answer. This is from Vivek, and he says, self-service for GPU is supported for both virtual machines or Kubernetes or both.
The short answer is both. I mean, the virtual machine or instance is very obvious. I think that's what Taylor showed us today. In Cloud Stack, we have multiple Kubernetes engine. The first one, of course, is the CKS, the inbuilt Cloud Stack Kubernetes service. The inbuilt Cloud Stack Kubernetes service allows people starting Cloud Stack version 4 or 21. We have some advanced feature where people can bring in their own templates. So if somebody wants to do, let's say, Taylor's demo, but on Kubernetes, the way you would want to do that is either create a template which has the NVIDIA GPU drivers installed, and while deploying and provisioning your CKS cluster, you would select a GPU-enabled service offering. What that will do is it will create worker nodes which have those GPUs attached, and if the template has GPU drivers installed, then your Kubernetes cluster will be able to sort of discover and make use of the underlying GPU resources and attach them to containers. However, this is not 100% like fully automated in the current version of Cloud Stack. After provisioning a CKS cluster, the user can SSH to their worker nodes, and they can customize, do some sort of internal plumbing. For example, if you've forgotten to install drivers, you can install the NVIDIA or GPU vendor specific drivers there, and then you can use kubectl or kubectl to configure your cluster. That's with CKS. If you're using capc or EKS anywhere, in those cases, those are actually something a lot of people use, and they customize their own templates. The same steps will go in those cases as well. The short answer is both, but for Kubernetes, some extra work may be required post creating your Kubernetes cluster.
Great, Rohit, thank you. All right, this next question is from Josh. I'm going to take an initial swing at it, and then I'd love to get Taylor and Rohit's opinion. So Josh says, great presentation. I have a client who is currently in a colo that's using virtualization and looking to get away from them and move to a different provider. In their dev shop, they started to experiment with open source, which is something we hear a lot, and wasn't sure if they could move away from their current virtualization platform, which I can infer as a production environment. What advice can you provide that would help them go down this path as they have 12 months until their colo contract is up and can build the confidence to bring their production to your OpenCloud? So I'll provide a couple of my thoughts, and then I'm interested in what Taylor and Rohit have to say. So, a few things from a confidence perspective. The first thing, and I know this is like, potentially not the most like sexy thing, but we have really great documentation. And so even as a non-OpenCloud user, we'll post a link in the chat to our public-facing documentation. It's not behind a login or a paywall or anything like that. To start taking a look at it, we've got overviews, we've got videos, we've got more in-depth technical detail that I think if it's a dev shop, they would love to consume that. In addition, we've got links to the Cloud Stack API documentation, which again, if they're deploying infrastructure as code or other types of applications, that'll be really helpful to get the the full understanding of the capabilities. The second thing I would say, and this is a little bit of shameless self-promotion, but we do free trials for OpenCloud. So there's a form on the website, which again, marketing can put in the comments, where a customer can sign up. There's no cost to consume the resources. Typical trials are 30 days. We can't roll them into production, but it gives you the ability to actually log into a GUI or a console and actually see what the OpenCloud environment is like. You can provision things. You can do all the things that a production customer could do within that trial. So those would be my 2 points. Taylor and Rohit, adopting open source. What do you guys think?
Yeah, I think it's definitely something that you want to explore, and with that, right, I don't know that you want to look at the environment holistically, right? What we would want to do is look app by app basis to say, hey, can in their current state we migrate to an open source environment that's going to support this? What is our deployment process? Are we doing manual deployments? Are we doing DevOps pipeline deployments? Right? Are we running containerized applications where honestly it may not really matter the underlying host, right? And then we want to look at kind of the support infrastructure around that. What's our observability platform? How are we tied into that? And when we look at all of that collectively, the ecosystem around open source is fantastic, right? Like if you look collectively at the largest companies in the world and what they're running, it's almost exclusively open source, especially for the largest software shops, right? So, to sit down, take a very app by app look, almost do a one-to-one comparison of what they're doing. The ecosystem's there to support it. And then it's just getting familiar with the tools. And to David's point, the documentation for the OpenCloud portion is fantastic. We have companies migrating all kinds of workloads into the environment, and then at an app level we can kind of say, hey, are there any gotchas? If so, and I would imagine they're probably not doing anything that isn't a solved problem in some fashion, right? How do we help them kind of through that journey? And again, to David's point, the trial is a great way to really start exploring that. Rohit, I don't know if you have anything else to add.
I think let me add a different sort of perspective to this, because it's a very broad question. I don't know there's one single answer which can satisfy all such cases. So it depends on what level of engagement do you want to engage with the underlying platform. Do you want to use open source software to solve your own problems, or do you want to use open source? Do you want to pick a vendor, pick somebody who's a leading solution provider, like in this case OpenCloud as a platform that you can consume, so which is based on open source technology, so which gives you all the things that you really want out of a platform, really, right? So you don't want vendor lock-in. At the same time, you want competitive pricing, you want support, you want, I think what David mentioned earlier in this talk, to be able to call somebody and get help from a real person. This is something you can't do with even very large public cloud providers. So that's the thing. The other thing is, do you want to do everything all by yourself, which in this case you can, from a ShapeBlue and open source Apache Cloud Stack perspective. It doesn't take a lot of time to set up and just try Cloud Stack. I think David and Taylor mentioned they have the OpenCloud demo. I think the link is in the chat that you can try. But there's also the underlying technology, which is Cloud Stack, that anybody can go download and try. It takes only maybe an hour or so to set up, like all in a one box setup, to just get familiar with the technology. Like, are you sold on the technology? On the confidence part, what I can say is world's largest e-commerce company, world's largest consumer electronics manufacturing company, one of the world's largest vaccination program, they all used Apache Cloud Stack. So just to give you confidence, you probably have heard it for the first time, but we have been there for more than a decade now. Many consumers, users, companies, enterprises, cloud builders, service providers, they have all been using Cloud Stack in one way or another way, and you can too. But the thing is, a lot of people want to use Cloud Stack, but let's say they don't want to handle support. They don't want to do things all by themselves. For them, something like OpenCloud can be a leading solution of what they are looking for, to be able to call somebody and say that I need this help, I just want to get things done. Because let's see in this way, people like bridges and roads because those are our infrastructure. People generally talk about bridges and roads when there are problems with the infrastructure. When it works, it's invisible for most of us. We care about the cars, we care about the things that run on the infrastructure. I'm assuming the person who's asked this question, they're running these cars and fancy gadgets on the infrastructure. They just don't like the underlying infrastructure for one or the other reason. So that could be other perspective to look about this.
Fantastic. That's a great analogy, Rohit. Thank you both for answers on that. All right, this next one I'll take, and then we've got a couple more questions before we wrap things up. So Dan asks, hey, just missed it. Can you repeat the timeline again? So just a reminder where we're at is the 4.21 release of CloudStack came out it was the end of August. I can't remember the exact date. That is really what we consider to be a technical beta as it relates to GPU as a service, not the rest of it, but GPU as a service. This is the first time it's been in a public release. So what you saw today in Taylor's demo is the L4 GPUs running on top of or inside of the 4.21 release. What we're going to do is 4.22 is really where we're likely to see the first production ready option. And so that, Rohit has stated is November, December timeline launch. We're going to follow very, very quickly behind that from a launch perspective. So my projection is sometime in Q1 of 2026. And then, all right, another question. Let's see, I just clicked out of it on accident. So Rohit, this might be for you. How many GPUs can I have on a single virtual machine? And are there any other enhancements planned in CloudStack around the GPU feature?
Thank you for the question. It really depends on the underlying hypervisor, the GPU drivers and whatnot. What we have tested and we have read based on, let's say, the NVIDIA and the AMD driver and GPU related documentation, it seems to be about 16. So you can plug in about 16 PCI devices. Those PCI devices can be your full pass-through GPUs. They can be vGPUs.
Got it. Thank you. And then any other enhancements planned right now on the cloud in CloudStack around GPU?
Really, we've shipped, I think, as David has shown in one of the slides, we've shipped the CloudStack GPU integration feature with CloudStack version 4.21 as a technical preview, what David likes to call the beta. And we are currently gathering inputs from the community, from OpenCloud, for example. We're collaborating with each one and everyone to figure out how can we polish this. As part of that, we have made some improvements. So in 4.22, you'll see some improvements on how on the flexibility side of the GPU integration features, which means ability to discover the GPUs better, to be able to allocate and use them in a better way. Other than that, we are also seeking for the community and OpenCloud to help test out this feature, report issues and bugs for us so that we can improve. 4.22 will be the next LTS release of CloudStack, which means it will be supported for the next 18 to 24 months, which means even if there are problems, you can start to use it in production, or at least start in your staging and lab environments. And as we get around the dot releases, which means 4.22.1 and .2 and .3, and we will deliver improvements and fixes in those releases.
Awesome. Thank you, Rohit. All right, there's one other question that, or two other questions I'm not sure we're going to have time for. So what we'll do is we'll make sure we answer them and get them out to the folks that asked. Thank you, everyone, for the questions. And, with just 3 minutes left, all presentations are somewhat self-serving, but I mean what I'm about to say genuinely. There's a survey. Once this go-to ends, we'll probably also do a follow-up email. The purpose of the survey is to influence what we build. It is not to go give this to an AI thing that's going to email you 1 million times, or have a bunch of salespeople calling you. We really want to know, what's your use case? So what are you trying to do? What's the application? What's the function? Why are you challenged? And we want to know, if you know, what are the GPUs you're interested in actually using? You may not know, and that's okay. Tell us the use case. We can help figure out the GPU side of it. But again, we have L4s in the lab. I don't think L4s are going to be the only option in production. In fact, I know they won't be. But what we need to know from our customers is, is it H100? Is it an Intel GPU? Is it an AMD GPU? That's really the feedback that we want. So don't be shocked if you fill out the form that I follow up with you. That is a possibility, because I might want to know more. But please let us know and influence, what we're doing. So with that said, we're just at the top of the hour. So I first want to say thank you to Rohit and Taylor. And also thank you to everyone for engagement and taking the time out of their morning or evening, depending on where you're at.
Here. Thank you, everyone. And thank you for having me, David and Taylor.
You bet.
Thanks for joining us.
Thank you.
Right. Take care, everyone.
Bye-bye.
Cheers.